Welcome to Rama Connecting, and today I came with a meditative lecture, and it's a gift for all those who are preparing for Jee Advanced 2026. And I'm really thankful for all of you to have immense trust in our team as well as for the great response to our book. And definitely will be keep our work as much as enlightened in the coming future as well. So in this series of lecture, it's going to be surprise. I'll add definitely enough lectures so that it'll be in a very good position to hit the Jee Advanced 2026, and it is lecture number 1. So let's start. Let's start with the first question. So welcome to the world of problem solving, where we enlighten you with level of problems and proper understanding without any flaw. So first question is very technically involved, and it asks you have to find the number of differentiable function y, which operates from minus infinity to infinity to 0 to infinity, such that dy by dx equal to 2 root y and y0 is 0. Option A is you have exactly one function, option B is 2, option C more than 2, and option D infinitely many. So let's see how a typical student solves it and what is the catch in this question. So it feels very obvious and easy question. So we can take dy by 2 root y dx over here, and then we'll integrate on both sides. Integration of dy by root y half times integration of dx, and it's root y equals x plus some constant. So this is a solution for every c belongs to real number. Initial condition gives y0 is 0, so that gives root 0 equals 0 plus c implies c equals 0, right? So which forces the solutions to be root y equal to x, and that gives y equal to x square. So very easily we attempted to tell answer is A, and that will award you minus 1 marks. Now that is really surprising. One of the obvious way to defend the answer cannot be A is if the function is identically 0, you see the domain. So what if I make identically 0, so yx is 0, which means function is 0 for all x belongs to R, then still that will satisfy. So till now I have already found two group of functions, 0 and x square. So answer cannot be 1, agar it will be C. Now unfortunately, then you will tell, okay fine, there has to be a constant function, we miss answer is 2. Now that's even wrong. One way is you can search for more answer, and the other way is let's see where is the flaw and what exactly is happening. In fact, the flaw is here. The moment you write this, so from this step to this step, we are allowed to go if and only if y is non-zero. And you see, just a small domain restrictions जो यहाँ पे है, वो आप कितना बड़ा प्रॉब्लम कर सकता है मैथमेटिकल फील्ड में, ठीक है? क्योंकि ये तब पॉसिबल है जब वी हैव टैक्टिकली एज्यूम्ड y इज नॉट इक्वल टू 0, लेकिन y एक इंटरवल में भी वैनिश कर सकता है. y कैन वैनिश इन इंटरवल. फॉर एग्जांपल, you can see this case. What if function would have been like till any particular value 1 0, and then it becomes some x square, maybe let's say x minus 1 whole square. What I'm telling is, what if I define function as 0 for x less than equal to 1 and x minus 1 whole square for x greater than 1. Now you can clearly see f dash x will be 0 for x less than 1, and it will be 2x minus 1 for x more than 1. And at x equal to 1, so still derivative is 0, because from LHL and RHL both functions will have the same slope, means this is a smooth function. Now this function is still satisfying this, because if you see dy by dx is t to root y, right? So that is literally interesting. In fact, all class of function will satisfy this. The reason being, since I have taken into country, I have not taken into consideration y is 0. So there has been a discontinuity somewhere in the process of outlining. Okay, the function is still holds. Instead of letting an interval in which it's true, we can assume interval from like minus infinity to any point 1 or 2. In fact, I can define functions from minus infinity to a point, let's say a, and again from a to infinity I can define x minus. So this is very important consideration when you see the number of differential functions. The answer goes to infinitely many, and I'm sure most of you must be surprised by a simple but beautiful question. Remember, this happened because I moved here under the condition y is not 0, right? So what if y is 0? So if I give y 0, I can stop anywhere on the number line, and that will give infinitely many solutions. Another way of doing this probably is you would have taken whole square in the beginning only, and then you can get y dash y double dash minus 2. But again, if the product of two functions is 0, not necessarily one of them is 0. Okay, we can have some rational and irrational definitions so that they might vanish differently. Let's try the second question in our series, and this is you have to find the number of continuous function f from 0 to 1 to minus infinity to infinity such that 0 to 1 f of x whole square dx 2 times 0 to 1 of x dx. Now this is quite interesting because you don't know about any function and neither you can use Leibniz rule. And remember, we want continuous function. Now, very interestingly, you can see if I'll put 0 to 1 f of x square minus if I bring that side, it gives a field of Golu square minus 2 Golu. So we'll add Golu. And since I've added 1, which means 0 to 1 integral 1 dx, I'll add that to another side to have marked balance. So it's 0 to 1 f of x minus 1 whole square. Right? That equals. Now what else you can do? What else we can do? But the function is defined from 0 to 1. The output is minus infinity to infinity. Right? So how many functions will work so that it will exactly be true? So you can clearly see if I call fx minus 1, since f is continuous, fx minus 1 is continuous, and let's call it some psi x. So psi x is a non-negative continuous function, right? Whose integral over 0 to 1 is 1. There are so many functions which will satisfy this. You can have so many continuous functions whose like integration will be 1 by, because 1 you can also assume to be an area bounded by a square. So maybe some area will be up, some down, and it will compensate to be 1. So answer is just still there are infinitely many such functions. Yes, now the question could have been, suppose somehow magically in question RHS becomes 0 and the function is continuous, then definitely you are left with only one answer, which is f of x equal to 1, which was of course not the case over here, right? Let's see the third one, and here we have to find the minimum value of mod z plus mod z minus 1 plus mod z minus I plus mod z minus I, and how we are going to go about it. So you can see in complex plane, basically we'll have this 4 complex number 0, 1, I, and 1 plus I. We have got this 4 complex number, and now if you have any variable guy p, want to minimize this, so the sum of distance has to be minimized, right? That's very obvious. If I call this point, let's say a, b, c, d, then from triangular inequality ap plus pc will definitely be greater than ac, and similarly pb plus pd will be greater than equal to pd. So if you'll see the minimum case, right, So here equality will be the minimum case because this guy will always be more than this. Here also equality will be the minimum case. The minimum case for PA plus PB plus PC plus PD has to be AC plus PD. Now let's see, can there exist a point which simultaneously makes both equal? Answer is of course yes. And that will exactly be the diagonal point. So for the sake of clarity, अगर मैं points को यहाँ ले आऊँ, diagonal के intersection is a junction from where PA plus PB plus PC plus PD will be minimized. And if we'll put this diagonal का intersection, आप देख सकते हो ये square है. The minimum distance is sum of this. It's 1 1 1 1. This guy is root 2. Root 2. So answer is 2 root 2. You don't need to do much calculations. Just triangle inequality in a very nice way worked. Let's move to the next question, the fourth one. Here we have 0 to infinity dx by 1 plus x whole square into 1 plus x square. Although it seems easy, and in fact it's easy, so immediately 1 plus x square gives a motivation of x equals 10 theta. That brings it to 0, so pi by 2. We have dx is secant square theta d theta. Denominator is secant square theta 1 plus 10 theta whole square. It gets killed, and now I can write it 0 say pi by 2 cos square by sine plus cos whole square d theta. We can make King's rule now, and we can replace this with sine square by sine plus cos whole square. What if we add both of them? So we have 2y आ जाएगा 0 से pi by 2 sine square cos square 1, so it's d theta y sin theta plus cos theta whole square, right? And sin theta plus cos theta you can write sine of theta plus pi by 4. So this basically went to 0 से pi by 4 cos secant square theta plus pi by 4 theta. अब इसका वैल्यू में आ गया -1/4 cot theta plus pi by 4 evaluated from 0 to pi by 2, which gives you 1/4 cot pi by 4 minus cot 3 pi by 4. और इसको इवेलुएट करोगे तो कितना 1/4 into 2, which will give half as the answer. So although it was simple question, but I am trying to bring you a rhythm, and slowly lecture wise इसका level बढ़ा होगा, and so that you could revise all the important ideas of the syllabus. Right. Let's move to the next question, and it's also a bit interesting. And the question tells, let n choose k equals n factorial by k factorial into n minus k factorial. Then we need to evaluate sigma 10 choose k square equals 0 to 10 1/2 का पावर 10. अब ये काफ़ी एस्टिमेटेड सवाल है और इसको आप सॉल्व कर सकते हो, सिंस वी नो 1 प्लस एक्स का पावर n इज सिग्मा n चूज k x का पावर k equals 0 to n. So to get k square over I need to differentiate it twice, right? So here particularly I am putting n as 10. So if I'll differentiate once, I'll get 1 plus x ka power 9 is sigma 10 choose k x k minus 1, and k goes to 1 to 10. We can further move ahead. We will get 91 plus x ka power 8 is sigma 10 choose k times k minus 1 x ka power k minus 2, right? And k still values from 2 to 10. Remember k is 2 now because otherwise we can't define with negative. And now what we can do, we can multiply them with x, the second equation, and add with the second. Multiply first with x and add with the second. So we'll get 10 times 1 plus x ka power 9 is sigma 10 choose k, because we want k square. So k square minus k and k will get cancelled. That's why we're doing that stuff. We'll get k square x ka power k minus 1 plus 10. And now just put x equal to 1, and k is a dummy variable. So k is running from 0 to 10. And that gives you directly sigma 10 choose k k square 1 by 2 to the power 10 k 0 to 10 just by putting 1 is 90 into 2 to the power 8 plus 10 into 2 to the power 9 by 2 to the power 10, and which will give 55 by 2. Although you can solve this question in another method as well. So usually if you see my binomial playlist, I have given a story logic to this, like PM and MP's logic. You can also do directly with the combinatorics logic with the sets. Here I wanted to be a little bit calculus driven. Now here comes a very interesting question, and it's real to see this question. So we have to find again the number of functions 0 to 3 by 2 operating to 0 to infinity. We have to find number of continuous functions such that it satisfies 4 times 0 to 3 by 2 f of x dx plus 125 0 to 3 by 2 dx by root. That's crazily beautiful. You don't need any method apart from the basic J syllabus, but it's such a nice. So we have given sum of two integral to be this, and in interval of integration is 0 to 2 by 3 by 2. So somehow we'll be tempted to first, like bring them. Sum of integral is integral of sum. So probably we can bring 0 to 3 by 2 because we don't know anything about functions. So it's 4 times f of x plus what else we can do. 125 we can send little there, right? So 4 times f of x, and idea will not come suddenly. So let's see how we can move about it. What else we can do in the solution? Okay, so how to think in such kind of problem? Now, clearly you can see we have some expression over here and f of x over here, right? So first is f of x, second is root over f plus x square, and f is unknown. So if somehow if this I would have brought f of x plus x square kind of a structure, then at least something common I could see, right? That can serve as a motivation because f of x is unknown. So either idea is f of x minus something whole square integral should be equal to 0 or less than equal to 0, so that it will be locked to a particular function as long as continuous, or we have to do, because since it's a positive restriction on output, so might be MGM or some stuff equality cases there, else we can end up with infinitely many solutions. So in order to get f of x plus x square as a motivation, so with this driving motivation I'm tempted to check what this, because if I bring f plus x square, definitely 0 to 3 by 2 x square dx I need to evaluate, और ये क्वांटिटी जो है अपने पास, क्योंकि 4 भी इसके पीछे है, तो let's evaluate 4 times this, and that gives 4 by 3 x cube evaluated from 0 to 3 by 2, and which comes to be 9 by 2. Okay, so 9 by 2 I can basically add both side. So let's have fun. Let's add 9 by 2 on both side. So we'll have 4 times 0 to 3 by 2 f of x dx, and then I can write 4 times 0 to 3 x squared dx 3 by 2, that is fundamentally 9 by 2. Okay, so I guess you are getting the very nice logic over here, and plus 125 0 to 3 by 2 dx by root over f of x plus x square. Cool. And then I have to add 9 by 2. So it's 216. So that gives 225 by 2. So this is what we're getting over here. And now it's quite cool. Cool in the sense like we can write this as 0 to 3 by 2 4 f of x plus x square plus of course dx plus 125 divided by root over f of x plus x square, this dx, right? If I take this together, and that's equals to 25. So if I'll take g of x as let's say f of x plus x square, then this entire function can be written as 0 to 3 by 2 4 g of x plus 125 by root g of x dx, and that becomes 225 by 2. Now again, something fascinating is there, because we can use maybe how to get this root over here. So either I can use 2 root gx, right? So maybe we can use a square plus b square plus 2ab root. Or probably, possibly, we can even think of inequality, right? Because g of x, remember, is a positive codomain. It has, so whatever range it will give. 0 to infinity is not range, it's codomain. So output of the function will definitely be from this subset. Okay, so this can be the range of this function. So one thing is which I'm pretty sure about is, like, this guy is getting equal to 0, this is also getting equal to 0. Of course I can't have denominator 0 because function is 0 is excluded in the output. So now let's find the minimum value of this. Possibly we might hit with the boundary case. So how to use AMG inequality? One thing is, you can take gx as u and use calculus to find the minima, but we can play safe over here, because I can bring two copy of root gx, so that after gm gets multiplied, root gx whole square आएगा और gx will be killed. इसको मैं 125 by 2 root gx लिख सकता हूँ. And now applies amma jimma, which is AMG inequality over here. So this by 3 is greater than or equal to third root times the product. I will see the product. It's 4 by 4. This g guy will get killed by root g. Oh, that's so insanely good. और ये सब कैंसिल हो जाएगा भाई. जैसे ही कैंसिल हो गया तो मेरे पास आ गया, इट्स एग्जैक्टली 125, राइट. ये चीज अपन के पास आ गया 125 into 3. So this quantity y3 will be third root of 125 whole square. Okay, so it's 125 ka power 2 by 3 into 3. And what is this? It's 5 cube. 25 into 3, which is 75. And that's really good. So this stuff I know now. 0 to 3 by 2, 4 times g plus 125 by root g dx is definitely greater than 0 to 3 by 2 and 75 dx, which means it's definitely more than 75 into 3 by 2, which gives 225 by 2. ओ माय गॉड भाई, क्या हो गया. एग्जैक्टली इक्वलिटी केस पे बनाया गया सवाल था. क्या जबरदस्त सवाल बनाया भाई. So this was exactly done with the equality case. इसका मतलब equality case will happen if and only if these three guys are equal. In these, this is equal to this. I have to consider all two of them is equal. And if you make them equal, you can see the functions also you can retrieve actually. So 4 times of g is 125 by 2 root g. That will give you g root g is 125 by 8. And now you can square, get g, and g I have already substituted. So if you will this, you will get f of x explicitly, I guess. Okay, so if you solve this, f of x, even it can be retrieved like corresponding to this function, you'll get that equality case. Okay, so it was extremely tricky, and accidentally you can solve it. नोवेटर डाटा वाज इतना सही तरीके से चूज किया गया था जो इक्वलिटी का इक्वलिटी केस होगा. ठीक है, अगर 108 के बदला आरएचएस में कोई और नंबर होता तो ये पूरा आर्गुमेंट जो है वो खत्म हो जाता. सो द स्पेशल thanks to this number 108, which is very sacred even in our Sanatan Sanskriti. And you see how sacred was in this problem. और ये 0 to infinity. So अब कैसे कोडोमेन से आप ट्रैक कर सकते हो. So hint of the problem was basically captured here, which gave AMG inequality, and the hint was more degree of freedom on the function itself. So I'm sure you like this problem, और इसमें आपको मजा आया होगा जो कैसे हम क्वेश्चंस को जो प्रॉपरली इसमें सॉल्व कर सकते हैं. एक और सवाल था जो हम लोगों ने अपने थीम बुक में आइडियाज़ में भी इंक्लूड किया था, And so let's try this problem. It's based on differentiability. So we have to find the number of values of x such that f of x is not differentiable, is not differentiable. So let's see how many questions we have. F of x is 1 1 1 mod x minus 1 mod x minus 2 x square x minus 1 whole square minus 2 whole square. Okay, so you can clearly see it's like 1a square, 1b square, 1cc square. So this is quite a standard determinant, 1a square, 1b square, 1cc square. इसको आप ऐसे भी सोच सकते हो. If I'll keep a as b, the first two rows will be same, that will be 0, hence we must have some stuff like a minus b, and the same argument b minus c, c minus a. This is known as cyclic determinant or van der Monde determinant. Now you might feel like why this coefficient cannot be a function of ABC. That is dimensional check, because we'll have L cube length, so AB square term is already present here. We have A and B and B with AB, so lambda must be a constant, it can't be dependent on A and B from the dimensionality और कंजर्वेशन ऑफ डायमेंशंस फ्रॉम बोथ साइड. डायमेंशन मतलब आप देखो इसका लेंथ है और इसका भी लेंथ है, सो मैक्सिमम एक्सप्रेशन विल गेट क्यूब like a b square term is already there, so you can't have some function of or b or c, so it must be constant. And now you can check coefficient of a b square will be actually 1, so this lambda must be 1, so this will be true actually by this simple logic. तो यहाँ से with less effort I can tell it will be mod x minus 1 minus mod x a minus b mod x minus 2 minus odd x minus 1 b minus c and mod x minus 2 minus mod x c minus c. अब अपन को चेक करना है ये किस किस पॉइंट पे डिफरेंशिएबल नहीं है. सो सिंस एब्सोल्यूट वैल्यू इज कंटिन्यूअस एवरीवेयर, तो ये फंक्शन तो पूरा कंटिन्यूअस है भाई. ठीक है, अब एफ ऑफ एक्स डिफरेंशिएबल जाएगा, वो आपको 1 पे चेक करना होगा, 2 पे चेक करना होगा और 0 पे चेक करना होगा. तो ओनली डेंजर इज 0 1 2, सो सेपरेटली विल चेक at 0 and 1 2, and that's fun actually, because at 0 if you'll see this quantity is already differentiable, it has no danger, this is differentiable, so overall this function will be differentiable. Just I need to check about this function, right? So if it is also differentiable, our is differentiable. If it is not differentiable, then we have to worry, because then if the other quantity becomes 0, then sharpness can be removed. Or you can assume x less than which is 0, and then function will become 1 minus x. You can open another way. So either you can give logic simply, or you can just do like a kid over here. And if I assume x to be between 0 to 1, so this function will open as 1 minus x minus x. You can see how bracket works, 2 minus x minus 1 and plus x. And that's also a fun game, because the next bracket will be 2 minus x minus x. That will give 4x square minus 6x plus 2, right? So now you can check the first and derivative, f dash 0 plus and f dash 0 minus, so it's 0. And here if I'll see f dash, so we'll have 8x minus 6 at 0, it's minus 6. So clearly it's not matching, the function is not differentiable at x equal to 0. Similarly, you can check for the other point, and the point of non-differentiability will be 0 and 2. So it was an excellent problem. You have to deal with the behavior of at every 3 suspicion point जो था आपको, जो danger point है 0 1 2 उस पे. ठीक है, तो आई होप मतलब आपको ये काफ़ी कुछ सीखने को मिला होगा इस पेपर से. So let's see, we can even go with another question. Mostly I'm training you for calculus heavily in this today's session. तो मैं और कमिंग मैट्रिसेस डिटरमिनेंट लाऊंगा, वेक्टर्स अलजेब्रा लाऊंगा. और आपको अगर ये सेशन अच्छा लग रहा है, डेफिनेटली आप यहाँ पे लाइक कर सकते हो, कमेंट करो भर भर के, और हम आपको और बेहतर क्वेश्चंस जो हैं वो आपको लाएंगे आपके सामने, right? So here is a question. Question tells that suppose f is a continuous function again from 0 to infinity to r, and that satisfies f of x equals 2 times 0 to x t f of t dt plus 1 for all x greater than 0. You have to find f of one value. Now this is a typical Newton's Leibniz form. So since f is a continuous function, so they have mentioned f is continuous. Remember, they did not mention f as differentiable. So how you can differentiate this? If you see any extended textbook, they will start differentiating this. Now the question is, am I allowed to differentiate when I have told only it's continuous? So function might have this coordinate point. The answer is surprisingly yes, and unfortunately, many of the textbook at G level they misses this extreme important fundamental theorem of integral calculus. So it tells if f of x is continuous, so f of t is continuous, then 0 set t f t fx dx will be differentiable function. It means just you need continuity of f to differentiate this integral 0 to t, and it makes sense actually. So what it tells fundamentally is if you have a continuous function no break, and integral 0 to x ft dt will represents the area function, right? It's like how much area you are taking. So area will be differentiable. It means the rate of change of area will be very small. Okay, and this is known as fundamental theorem of integral calculus. In fact, first fundamental theorem. So with that, I can tell since ft is continuous, so tft is continuous, product of two continuous. Hence this guy will be differentiable. One is differentiable. Product with two is differentiable. Since RH is differentiable, hence f is differentiable. So differentiability of f is a consequence of this integral theorem, right? Rather than just assuming anything. तो मैं कुछ assume नहीं कर रहा हूँ. So now I can differentiate and I can tell f dash x is 2x f of x. यहाँ से Leibniz rule से you put x ऊपर वाला है here and then differentiate. And this would be true for all x greater than 0. So if I integrate both sides, I'll get ln fx is x square plus constant. So hence f of x can be written as e ka power x square plus constant. So e ka power x square into e ka power c, that is lambda e ka power. Remember, lambda is also a positive constant here because it's e ka power something. So if I apply f0 as 1, it's straightforward, give f1 as. So once fundamental theorem of calculus strikes, this becomes very easy. But I guess JEE means JEE Advanced especially can make an option where they can tell the function need not be differentiable, and many students will definitely get trapped. Okay, even a good kid. So that was again a very great learning over here. Although you can also solve this problem in another method, which is very typical method when you apply mean value theorem or Rawls theorem. So I can also take f dash minus 2xf at 0, and we can think of a function whose derivative is this, right? So basically, if you multiply by the integrating factor, is linear differential equation. So it's dy dx of e ka power minus x square will be integrating factor f of x, which means this guy is constant because we are in an interval. The function is defined from 0 to infinity. So in this entire interval, and that's very important because if derivative is constant, if derivative is 0, it might be a different constant at different level. Okay, so it might not be same constant. Again, it follows from mean value theorem by the connectedness of interval. So whether intervals are disjoint union or joint union, that also matters. So I can tell this must be constant in that interval. That gives again the same answer. Okay, from the boundary condition, whatever you take. So this was also a kind of cool question to be done in the exam. Let's come to a nice problem of ITF, and the problem goes like this. So they tell you tan inverse x square plus 1 plus tan inverse x4 plus 1 plus tan inverse x8 plus 1 is equal to 1 by 2. And find the number of solution. Find number of x belongs to 0. They will not ask solution, number of solutions. So one way of doing this problem will definitely be like, I can start with tan inverse a plus tan inverse b formula. And since all of them is positive, so remember tan inverse of Golu, if Golu is positive, will belongs to 0 to pi by 2. But it can be done in a very really cool way, because you can see all these functions are strictly increasing. Tan inverse is a strictly increasing function. If I were to graph like this, so now the sum of increasing function will definitely be increasing. So more or less the nature of function is going to be this. Okay, of course at infinity it will be all. So if I'll graph this stuff at infinity, it's going to be 3 pi by 2, right? And even at minus infinity, since it's even function, so more or less is going to be this, right? And now I can easily tell, if I'll keep x equals half, so output is half, which is definitely lesser than 3 by 2. So the answer I'm going to be two solutions. So sometimes you see, without solving anything, it's very obvious for most of the question that you can deal with the situation in a nicer way, right? Let's move back to the next problem, and it's really interesting to note that we can even solve some of the really beautiful problem by very fundamental method. So in this series, where mostly I dealt with calculus problem, let f be a function defined from 0 to 1 to 0 to 1 be continuous, such that x square plus f of x whole square less than equal to 1 for all x belongs to 0 to 1, and 0 to 1 f of x dx is pi by 4. Then we have to find the value of half 1 by root 2 f of x by 1 minus x squared. Again, now it's surprisingly beautiful question, because the constant is an inequality. So it's rare to see an inequality constant. So, and how we are going to have a fixed value of this function. So the first thing that we can immediately see from the constant is x square plus fx whole square is less than equal to 1. So that shows fx whole square is less than equal to 1 minus x square. And function is defined from 0 to 1 to 0 to 1, means we have to be within this box, whatever function it is. Cool. So since fx is positive, so I can take a square root on both sides, and both quantity is positive. Input is also 0 to 1. So I'm allowed legally, so it's mod of f of x. You see, you should do all legal step, because root of s square is mod. And now f output is 0 to 1, so I'm allowed to put f of x is less than 1 minus x square. Correct. Now since f of x and this guy is both positive, and root over 1 minus x square, if we plot at x0, so roughly we'll get this graph. And f of x can be either equal or less. So area wise, definitely the area of f of x will be lesser. So in 0 to 1, I can tell f of x dx is definitely lesser than 0 to 1 root over 1 minus x squared dx. And root over x minus squared dx is anyway, it's very simple, because this quantity is just area of this quarter circle. So this guy is pi by 4. Now you see, what is happening over here is we got 0 to 1 f of x dx is less than equal to pi by 4, right? But the question restriction is given 0 to f of x dx is pi by 4. So It means like our function f of x, in fact, it's an equality case. So this equality case will come when the area is exactly overlapping, right? And for area to have exact overlap, the function is unique over here, root over 1 minus x square. Those who are writing ISI exam, you can even do it more rigorously. You can define psi to be 1 minus x square minus f of x. And now you see g of x, this psi is greater than 0 at all point. So if any size is greater than 0 for some, then there will be some delta, like such that in every interval it will be. So indirectly you can prove 0 to 1 gx is 0, so it will be contradiction. Okay, so the same logic which I have told graphically, that equality case, the only way the function will be equal is when that function exactly becomes that same order circular arc, can be done more rigorously in algebraic way also. Now once you know function is root over 1 minus x square, the question is almost killed, because it's 1 by 2, so 1 by root 2 dx by, it becomes dx by root over 1 minus x square. And this, it's sine inverse x evaluated at half and 1 by root 2. So it's sine inverse 1 by root 2 minus sine inverse half, and that gives you pi by 4 minus pi by 6, and which packs it up at pi by 12. So it was again, a very excellent problem, I'll tell, with the inequality, and how those is giving an equality cases in a very beautiful way. I'm sure you are enjoying the session, और इसमें काफ़ी मेहनत भी लगता है बाबू, 12 बजे रात में आपके लिए वीडियो रिकॉर्ड करना, because we think like अगर we can impact inequality to you, so it will be of great use. One more problem is there, and I'm sure you can do it. So you have to find the number of real solution if cos square x sine 2x plus 1 by 1 plus x square is cos square x plus secant square x. Now clearly you can see this guy will be cos square x plus 1 by cos square x by mgm. This will get an equal to 2. So RHS is greater than equal to 2. What about LHS? Right? And now you can see this quantity will definitely be fraction, and this quantity cos square something will definitely be less than equal to 1. So this guy is less than equal to 1, and if x square getting 0, so this will strictly be less than equal to 1, right? So the only way to have both equal, so if x is anything non-zero, then RHS is going to be more than 2, but LHS is going to be definitely strictly lesser than 2. So there is no hope for any solution at x less than 0, like non-zero. So the only possibility is x equal to 0, and if we'll check, it's cos 0 is 1 plus 1 is equals to 2, and that works. So this question was very cosmetically developed, to match the extreme case, and the answer is number of solution is just 1. So sometimes you have to be literally alert for even these kind of problems, right? Let's pack it up with the last problem, and you see how fundamental matters. So if I have a function defined from -1 to 1 to r, and it's defined by f of x is x square mod cos pi by x for x not equal to 0, and is 0 for x equals to 0. So you have to find the points such that f dash x does not exist. So S is the set of all x so that finds set S, number of points in set S. So clearly we can see, first we'll check with 0, right? And then we also have points where this guy dies, because if this dies, still there is a danger. So for cos pi x mod to be 0 means basically inside and stuff to be 0, pi by x would be 2n plus 1 pi by 2. So pi cancel and that gives x equals 2 by 2n plus 1, right? So what will get over here? If you see the values, let's say at 2 by 3, okay, fine, yeah. 65 by 2 base will be 0 and then mod will have a corner set. So at all values of all multiple of odd multiple of pi, this basically dimensions 2 by 2 n plus only all range and point, and there it does not exist. What about 0? So we can calculate f dash 0 separately, because you can't differentiate and show the differentiability. That can be done if and only if the function is continuously differentiable. Continuously differentiable means f dash itself is continuous. Then you can check f dash from left hand side and right hand side and make it equal. Again, that's a great misconception in J world. So if a function is continuous, that itself is not sufficient condition to find f dash 0 plus f dash 0 minus an equator. Okay, probably in next session I'll take some questions to illustrate that as well. So f dash 0, if I'll take its limit x tends to 0, f of x minus f0 by x. और यहाँ पे अगर अपन डेफिनेशन लगा देते हैं तो इट्स f of x is x square mod cos pi by x minus f0 is 0 by x. So x cancel and x tends to 0, this becomes 0 into cos infinity mod, and 0 into something dancing from 0 to 1, right? So that's anyway finite. So limit is going towards some finite value. So f dash 0 exists, then it's 0. So you can tell basically all minus 1 to 1 may it will be differentiable because the function was defined to this. So x differentiable point is this. Except at those 2 by 2 n plus 1. Okay, so you can tell it's all x such that x is 2 by 2 n plus 1 where l belongs to integer is the point of non-differentiability, right? So this is something which you can deal with this situation. Let's conclude this with the next question, and that should be more fun. So here is the question. I have an ellipse E given by x square plus 4 by y square by 3 equals 1. And on this ellipse, we are taking points. Let's call a point with x coordinate x naught, comma y naught. And his question is given so that x naught belongs to half, comma 1 by 3. Right? And now you draw the tangent at that point, any point. So family of points are there. On that you draw a tangent. Let's say the first focus is S1 and S2. I'm not giving you the language, just the theme of the problem. Let's say this perpendicular distance from the midpoint of S1 S2, which is origin, is D, right? And it's so interesting question. And now you have to find the maximum value of PS1, PS2, and DS square plus minimum value of PS1, PS2, DS square divided by max of PS1, PS2, DS square. Okay, so this ratio actually you need to calculate. So basically we need to find mean by max of this, and you'll be surprised to know the answer will be, and that I want you to sketch by yourself. So no matter where you draw a tangent, actually PS1, PS2 and DS square is going to be constant. and this constant will be just a square b square for ellipse. So basically my claim is, when I want you to write equations or do it smartly using geometry if possible, you take any tangent, and it's a very great property of ellipse. You take any tangent p, you take the product of distance ps1 into ps2, and then multiply with that distance of center to the tangent line, let's call d. Definitely this foot of perpendicular will lie on auxiliary circle. So if you multiply this with d square, that will be constant throughout. And this constant, when p is on the extreme minor axis endpoints, will be a square b square. And that's not very difficult to see why these constants will term up like this. So I wanted to prove a very interesting and exciting property, because these guys will be same, and if some distance is 2a, so this is a and a, and this point distance will be definitely b. You can see it's a into p, and that gives a square b square once you know that distance is preserved. Okay, so as if I take a secant theta comma tan theta, so what I'm telling is ps1 and ps2 times d square, this becomes constant because f dash theta will become 0. So I want you to think over this, and with this I finish our first session of Jee Advanced preparation, and I'm sure all of you have learned a lot from this. So let me just recapitulate. We have seen a differential equation solution is not unique in general, which is against our common sense. Second, we have seen how we can interpret the AMG inequality or the boundary conditions for integral, especially they can play with fundamental inequality. Third one, with the complex minimization and maximization can be visualized using geometry. Fourth one, a typical substitution. Fifth one, you can use calculus to use binomial theorem. And then we have seen a very beautiful problem of AMG inequality involving integration. Different non-differentiability, you can actually open it with a bit of determinant touch and then take cases, and you can do, or using theorems of f into g differentiability. Then we have seen important integral theorem which is missed out by a lot of kids, where only continuity was sufficient to tell the function is differentiable, which can be kept in one of the options in Jee Advanced. We move next to a very beautiful problem of inverse trigonometric function, and noticed that we have got three increasing functions, so the sum of increasing has to be increasing, and without any calculation we found the answer is 2 because the graph was an even one. Then the second last question we hit was an inequality, and again as usual we got the equality case of inequality, and the function rigorously can be done as root of 1 minus x square. Then we moved ahead with a trigonometric question where again it was a boundary level question. Next was a differentiability question, where the danger of differentiality will always be the stuff inside mod, because that is the probable source of corner points. And we have also realized that you can't just differentiate from both sides and equate it until function is continuously differentiable. It means the derivative of function has to be continuous. I concluded this entire lecture with a beautiful result which I want you to do by yourself, and the answer for this problem you will tell in the comment section. In fact, it's now all of you know it's 2. So ps1 ps2 d square is invariant in the location of p throughout the ellipse. And I would like some beautiful, elegant geometrical solution to it if anyone could have. The hint is that point p lie on auxiliary circle. Okay, so I'll meet with the next session, and if you want the next lecture to come with more algebra, with more integration, and throughout oriented geometry matrices, please do like and subscribe my channel, because you guys are not spreading it at all. So this content was meant to be shared as a paid content and only for members. But I've decided to give you these 4 lectures or upcoming few lectures if our views and the attractions will be more, then definitely I'll come and serve you with more content, because that keeps us motivated. Thank you. Thanks for your trust in us.